Okay guys, we're back. Same data set with the 10, but I'm gonna bring over my handy dandy paper where I already put them in order. And then my other paper where I'm actually gonna find the mean. Yes, I know the easier way is to just use the calculator, but we're gonna do it with your original calculator you were born with, which is your brain. So, add step by step. Ms. Garza does not ever recommend you adding all the numbers at one time, because that's where silly mistakes come into place. 6, 12, 13. And I do miss having y'all around because y'all are Miss Garza's checkers. And you like to call out to me when Miss Garza makes silly mistakes. And I miss that. When I'm all by myself, there's nobody here to check me and say, wait a minute, wait a minute, wait a minute. So I'll just have to keep trucking on through without you to check me right now. 7, 8, 9. Oops, 4, 8 tenths, 9, 3, 1, plus 58 and 9 tenths. Now I did check this with a calculator earlier, just in case Miss Garza made a mistake, and that is what I got. So now that I found it, remember mean is add all numbers, then divide by the number in your data set. So right here I have 58 and 9 tenths divided by 10. Miss Garza is going to do a review on how to write these numbers, the division 3 ways, just to review that T. So I could write it this way, I could write it this way, and I could write it this way. So 58 and 9 tenths divided by 10. I have 5 tens. I cannot share that with 10 people. Now I have 50 ones. I can share that with 10 people. I have 8 and 9 tenths to share with 9 people. Each person would get approximately 8. I can add another 0 to bring down. And it goes in nicely. So my mean is 5 and 89 hundredths. So on my paper over here, oh, let's not bring this guy back. I love when my markers run out of ink, and now y'all are not around, so I can blame you for it. Miss Garza's only to blame for running out of ink on that one. So the mean is 5 and 89 hundredths. Now let me tell you something on this one right here. If these 3 were the same, this is just a little side piece as far as what it would look like when you graphed it. If all 3 of these are the same, it would be called symmetrical or unimodal. That means your whole distribution would kind of look like that. Everything would be the same. But they're not, but they're close to being symmetrical because these are only 1/100th from each other. Now, this is the easy one, the mode. Remember our silly little saying of the commode is the most used seat in the house. So the mode is the most number you see used most often. So the number that appears most often, just like your commode, is the seat you use the most often. So in my data set right here, where I put them in ascending order, you can't find the mode. Well, you can, but it's a lot easier if you put them in ascending order. This one's only listed once, only once, only once, only once, only once. This one's twice, once, once, once. So since this comes the most often in this data set, it is our mode. So 6 and 3/10. We already found one of the measures of spread, which is the interquartile range. That was from our other sheet we just did. And the inner quartile range was Q1, my Q3 minus Q1. My sheet over here, my inner quartile range was 1 4/10. And my range is just the Lone Ranger looks high and low for danger. So we're going to look at the highest number and the lowest number, and we're just going to subtract them. So my highest, come back here, pencil. My highest number, so another note taking, range, highest minus lowest, number, 7 4/10 minus 4 8/10. 2 6/10. Okay, and then over here I'm going to plot them on my stem and leaf. Your stems are your, over here it's not going to be your tens and ones, it's your whole number versus your decimal. So my key down here needs to say that. So let's say if I had a number like this, 1/2, that would be 1 2/10. So your key down here tells the reader and the math interpreter right here, how do I read this stem and leaf plot? So I'm going to take my numbers from my original data set over here, and I'm going to put them in order. 4 8/10, 4 9/10. Any more 4s? No. 5 0/10, 5 2/10, 5 5/10. We do not plot that 5 9/10 because the median was not part of our data set originally. Then 6 3/10, 6 3/10, 6 4/10, 7 1/10, 7 4/10. Remember I started with 10 numbers, so how many should be here? You guessed it, 10. 1 2 3 4 5 6 7 8 9 10. Remember, mathematicians are precise, so Ms. Garza is going to keep going back to model what good mathematicians do, which is to check and be precise. So this was a frequent question we asked. Ms. Garza, what is the measure of central? And what if they're the same? That would mean you had two medians that were the same. Your central tendencies describe the central behavior of your data set. Your measures of spread, there's two of them. The range, and then you have inner quartile range. That just means what does it look like from one point to the other, the spread of things. And then your distribution summary. This is going to summarize your data that you've been working with. It says percent, so I'm going to make sure all of my numbers are in percentages. So first off, I'm going to start with the number of earthworms between 4 and 5. That is 2. I know it says percent, but I'm going to write down my numbers first and then find the percentages. How many earthworms measure between 4 and 9/10 and 6? So that's between 1, 2, 3. How many earthworms measure between 5 and 9/10 and 7? 1, 2, 3. How many earthworms measure between 7 and 8? 2. And then how many earthworms are greater than 8? 0. So again, reiterating, there were 10 here, so I should still have 10 here. And that was so nice of Ms. Garza to make it 10 because 10 works so well with 100%. So there's 2, 5, 6, 7, 8, 9, 10. Perfect. Now I just make percentages. Since Ms. Garza was so nice and kept it at 10, all we have to do is multiply each number by 10 to get to 100. So 2 times 10 is 20%. 3 times 10 is 30%. 3 times 10 is 30%. And 2 times 10 is 20%. Even when we've checked it already, we're going to check to make sure that equals 100%. 20 plus 30 is 50, 50 plus 30 is 80, and 80 plus 20 is 100%. Now, boys and girls, keep these notes if you need to write them down. I just purchased some pink paper. Remember, Miss Garza likes color in her life, so I got pink paper. I keep my notes with me. If you need to take notes on this, if you need to write down notes, because next week you'll receive 2 different situations. Some of them may be stem and leaf, some of them may be dot plots. All of them are going to ask you to interpret the data. That is very important. So I will try to make it a shorter list of numbers, because remember, to be a good mathematician, it doesn't mean that you can take all of these numbers and do something with them. It's that you can do it precisely, and you can do it and always have that growth mindset. So I am going to cut down on the numbers. I'm going to try to give you smaller amounts of numbers, because I care more if you can do this than if you can do an entire set of 20. So take notes, keep track of them, save this video. It will be uploaded in the classroom stream for you to use next week.